Okay, so the isEmpty command is kind of a way of asking if the find command would return any values at all. When find doesn't return any indices, it returns an empty matrix. And you could then test if that matrix is empty. So let's try this. A is equal to 1, 2, 3, 1, 4, 8. B is equal to find when A is equal to 1. You get a couple times where A is equal to 1. What about C is equal to find A is equal to 1,000? C is an empty matrix, 0 by 1. So now we could say is empty C, and it is, but it's A, no, and it's B, no. So you could imagine what would happen if we say if is empty C, we can type in it worked. Otherwise, I'm screwed. So you can test if there were anything in your matrix that was equal to something, or if there was nothing. So let's try to consolidate some of these ideas into this exercise, where we write a program that finds all RTs smaller than 150 and larger than 1,000, calculates the average RT of the valid RTs, not including those, and reports the proportion of rejected RTs. Let's create the following vector, a random set of random RTs. So let's go clear all, close all, and CLC. And at the first, let's do this using for loops. So let's make a new script up here, and we'll start just by typing it down here. Rand 1,000 1. So you have 1,000 numbers between 0 and 1, and we're going to multiply that by 1,100. So we get lots of numbers between 0 and 1, and we multiply them by 1,100 to get a range of numbers between 0 and 1,100. And there's our data. You can click on it and see what it looks like. And it's just a bunch of these numbers between 0 and 1,100. So if we want to do this with a for loop, we should do something like this. We could say that the size is equal to the size of data, which we know is 1,000. We could make a counter, and that'll be a counter of all the times where we reject the data. And we could say that the mean at the start is 0. We want to compute this mean over the data. So we could say for I equals 1 until it's equal to the first value of size, which is the length of size, 1,000, how many variables there are. We'll go through each of them one at a time. This is 819, then 981, 266, 142. And we'll say if data I is greater than 150, if it's a valid RT, and if data I is less than 1,000, then we want to add it to the mean. Otherwise, if it's not less than 1,000, but it's still greater than 150, we're inside that loop, we'll say that the counter equals counter plus 1. Increase the counter. Then, if the data was not even greater than 150, we also want to add to the counter. We could have done a different counter for when it was less than or when it was greater than, but we'll put it all in the same counter. And then we want to end that as well. And then we're going to end this original loop that goes through our data one at a time. So let's see what would happen here. We say if the data is greater than 150, which it is. If the data is less than 1,000, it is. So we'll say the mean is equal to the mean plus data. We'll add that to the mean here. And we'll do that there. We'll add it that one. We'll add that one. But here, once it's not greater than 150, we won't add it to the mean. We'll get to here, and we'll add 1 to the counter. That will count this time as one of the times where there is an invalid RT. Now we're going to want to find the overall mean. And we're also going to want to count the proportion of rejected trials. So we could say that the mean is equal to the mean, which is the sum of all the numbers. We need to divide it by how many there are. So we could say the mean divided by the total list size minus the counter, because that's how many remain after we've taken those out. And we should put brackets around here so that it gets evaluated first. And then we should also say that rejected is equal to the counter size divided by the size of the overall amount. So I think we should be able to copy this. Oh, let's put this at the beginning of our code too. And we'll put a clear all CLC. So now we should be able to run Control A to highlight everything and evaluate it. And we should see here a new set of data that's different because it's random. And we'll say that the mean was 574. And if we go back to our workspace, the proportion rejected was 0.217. So out of every 100, 21 of them were rejected, and out of our 1,217, the counter here were rejected. So that's how you would do that in a for loop. What if we had to do this without a for loop, based off some of the stuff we learned about if statements and also about is empty? Well, without a for loop, we can edit our code like such. We can say the same, we'll generate data. Oops, sorry, I'm going to go back. We're generating data in the same way, but now we can find it all in one big shot. So we can say, let's delete everything here, and we'll say that bad RT index is equal to, I'll just keep it as bad RT is equal to find RT is less than 150, or RT is greater than 1,000. And now, if we run that, we should be able to get and we should rename this RT so that works with our code. So now we have RTs, and we have the bad RTs here anytime. And let's see what this is. This looks like indices, so it's finding us all the indices where this value RT was, so let's look at the first one, is 5. So if we look at the fifth one here, it's 1,063 milliseconds, which is greater than 1,000, and so it's flagged that as a bad RT. Notice how this is kept as a times 10 to the power of 3. That's what this E plus 03 means, which you might remember from your calculators. 1, 2, 3 means it's 1,063. So now we could say we'll make this new list of RT and we'll make it equal to the original RT. Now, we could then say if not is empty, so that would mean if it does have some values, this bad RT, then we want to say trim RT at bad RT is gone. We want to take it out. And then we'll say that mean RT is equal to the mean of that new trimmed RT. We've taken all the values out that are bad. And then we can say else. That means that else means that if this is empty, if there were no bad RTs, then we don't need to trim anything. So we can then just say mean RT equals the mean of the original RT. And then we can end it. And the last thing we're going to need to do for this assignment is find the proportion. So we could say proportion reject. And so the proportion reject, we have the length of RT, that's the total amount we had. We also have the length of trim RT, and we want to divide one by the other. So let's run this whole part up here first. And we'll look in our workspace and we find that trim RT, remember, is just the good ones now that we've taken all the bad ones out. Bad RT is 229. So if we were to go 1 minus the length of the good ones, just close that loop there, then we should find that our proportion reject, oops, looks like we missed a bracket here. There we go. Proportion reject is 0.229. So another thing we could have done here, obviously, is said length of bad RT divided by the length of RT would have given us the same value, 0.229. Now we're going to get into a new way of storing our data called tables, and I'll get into it for 4 minutes in this video, and then we'll start in the next video and continue. Now that we have this idea about isEmpty and also the string compare features and how to work with RTs. So let's create a variable called trial that has the numbers 1 to 1,000 and increments of 1, just counting 1 to 1,000. And another variable condition that has the numbers 0 or 1 alternating, so 0, 1, 0, 1, 0, 1 1,000 times in a separate column. Now we have data to store. So we might have trial is equal to 1 to 1,000. And so if we click on trial, oh, it's a row, so we want to actually turn that into a column. And now it should, if we look at trial, maybe we have to put that in these square brackets. Now we have the big column here of numbers. Now, what about condition? Well, we'll use this modulo, and it will find all the even numbers, and there won't be a remainder when you divide them by 2. And all the odd numbers, there will be a remainder of 1. So it will go 0, 1, 0, 1, 0, 1, 0, 1. So we'll say condition equals modulo trial 2. So now we have a bunch of zeros and a bunch of ones that seem to be alternating. And let's look at it here in condition. 1, 0, 1, 0, 1, 0, 1, 0. So that's a column, and this is a column. And so we've done so far what we need to do. Now, we have to put this data somewhere and store it in a way that we know that each row corresponds to common elements. So in the next video, we'll cover this use of tables. You can use Matlab kind of like you're using Excel. You can have a name of each variable and have all the values for each subject. You can sort by certain variables or certain columns, and you can even treat it like a matrix still and extract certain subsets of the data from in certain ranges or with certain conditional statements. There's some good functions that we can use, like table, array to table, cell to table, and structure to table, and we're going to first focus on table in this next video. See you there.